Hey there, geometry. Today we're going to do 10.4, use inscribed angles and polygons. So first, let's just talk about something. What we've been dealing with this whole time are central angles. So what are central angles? Angles that come from the center. Let's say this is 120, let's say that's 120 degrees. That means this arc over here from A to B, the arc measurement, is also 120 degrees. And they're equal when it's the center angle from the arc measurement. So much so that sometimes we just call one the other without any rhyme or reason. Like we'll make a mistake. Oh, this is 120 when we meant that, but it's the same thing. Now we're going to deal with inscribed angles. And how are inscribed angles different? Well, inscribed angle is an angle where let's say the vertex of the angle is at the side of a circle. So right here, this is a inscribed angle. What I drew before was a central angle. So an inscribed angle also have the intercepted arc. So that's the arc where the opening of the angle covers, right? So the relationship between an arc, and I need to put a C here. So the relationship between an arc and its inscribed angle is this. An arc is always going to be twice as much as the inscribed angle. So if this is 120, this is going to be half of that, 60 degrees. So now we have to be very careful when I say the measurement of the arc versus the measurement of the angle. They're now going to be different. Before, we didn't really care because they're exactly the same. Now, since the arc could tell us the inscribed angle and the angle could give us the arc, we could do a bunch of things with that. For example, here's one concept. Let me just erase that. Let's say you have DE here. I'll use different letters. And I tell you this line is a diameter. Well, remember diameters cut the circle into 180 degrees. So that means if I know this is a diameter, I can make any inscribed angle. So it could look like this, or it could look like, I'll use a dotted line this. And it could be like any point along the side. Since this right here, this arc is 180 degrees, and we know that because the diameter makes it into semicircles, and half a circle is 180 degrees, that means an angle like this dotted line is going to be half of this, of the intercepted arc. So that would be 90. Or something like this would be 90. And what's really important about that is that because the arc is like this, if the angle intercepts the same arc, what do I mean by that? That means the angle N has the same endpoints. No matter if it's here or somewhere in between, it's going to also be 90 degrees. So they share the same distance, or they're congruent angles because they share the same arc. They're congruent angles because they share the same arc. So the fact that the arc being shared between two angles make the two angles congruent is going to be a very important rule, and we'll see that during the homework samples, how that shows up. Let's go to the next thing, which is dealing with polygons, so actual shapes inside the circle. Okay. So with that rule that we understand, there's a couple of things we could tell. First off, if we have, let's say, a triangle, inside the circle, and we know it's a right triangle. So here's the first thing. It's a triangle in a circle, and we know it's a right triangle. We know for a fact that the right triangle's hypotenuse is the diameter. How do I know that for a fact? If this angle here is 90 and made it a right triangle, that means the arc measurement has to be twice as much as 90, or 180 degrees. If this is 180 degrees, that means the line from A to C has to be a straight diameter. So that's the reasoning. If you have a right triangle, you know the hypotenuse is the diameter. And the reverse is true also. If you have a triangle where one of the sides are diameter, that means this is 180 degrees, which means this angle right here is 90. So that means it's a right triangle. Okay? Pretty simple rule there. The next one is, I think, the more interesting of the two. Let's say you have a circle. That's a nice one, actually. And you have a inscribed quadrilateral. So what's a quadrilateral again? We did work a lot with it, but quadrilateral is a four-sided shape. Let's see if I could draw this well. Ugh. And this has to be inscribed. Okay. So, this is a quadrilateral, and let me put some letters. This quadrilateral A, B, C, D. It's not necessarily a parallelogram or any of those special ones. It's just a four-sided shape. That's as much as, what did you see? A, B, C, D. It's a four-sided shape, not necessarily a parallelogram or a rectangle. Okay, it's just a four-sided shape. Well, here's something pretty interesting. For angle A, right, at angle A, let's say DAB, it covers this much, right? Like that, right? And then angle C, so this angle right here covers this much of the circle. The diagonal angle, so the one across of it, covers, let me see if I can use a different color, covers this much over here. So angle C over here covers this much over here. So what do the two angles cover? The two opposite angles of a polygon cover the whole circle. So if I know that these arcs add up to a whole circle, which is 360 degrees, these two added together has to equal half of the arcs they match up. So if this is 360 degrees, these two angles right here should add up to 180 because the whole circle is 360 degrees. So what does that tell me? That tells me if a polygon is inside the circle, it has to follow this. Angle A plus angle C has to equal 180 degrees. We had a word for that. That means the opposite angles have to be supplementary. That's true for the other set of angles. Angle B plus angle D have to equal 180, or in other words, have to be supplementary. So opposite angles of a polygon have to be supplementary. And then we could do some questions based off that information. Okay, I erased the things and I just try to redraw it and use the same shape. But now I put a little bit of numbers here. This is going to be a 2x. So what's the rule that I know? I know the opposite angles of a polygon have to be supplementary, or it doesn't actually fit in the circle like this. It's forced to be supplementary. So let's look at the blue first. 80 and 2x. Well, 80 plus 2x, I said, has to be supplementary, so that has to add up to 180. Do a little algebra. 2x equals 100. X equals 50. Also with the y, same situation. It has to equal 180. So 95 plus y equals 180. Do a little algebra. Y should equal 85. So with that information that they are supplementary, we could use that to our advantage. All right, that's your lesson. Make sure to come on the Zoom for the homework. Yep, that's it. Have a wonderful day.